Hello AP Calculus class. Today we will be talking about what a derivative is exactly. Obviously the derivative is a very important concept that you will use for the rest of the year. So I'm going to attempt to make the concept as easy as possible, but I apologize beforehand for any confusion. So just to begin, this will be probably a really easy review for you all. So here's your x-axis and your y-axis, and you have the line y equals x. So in algebra, you have probably already learned how to find the slope of this line. Easy. Change in y over the change in x. That is your slope. In other words, delta y over delta x, right? So, and that will give you the slope of the entire line. So that's pretty easy since the slope is uniform all throughout the function you are given. In calculus, however, it's not going to be that simple. So in calculus, you'd be given a function more like this. This is, of course, as you know, y equals x squared. How do we find the slope of this curve? Well, let's just think about it. How can we find a slope of a curve whose slope keeps on changing? Well, if you see here, the slope is 0. But as we keep going rightwards, the slope is increasing as it gets steeper and steeper and steeper. The slope of this point would be different than the slope of this point. So the derivative is useful in finding the instantaneous slope of a point. The slope of this point would actually be the same as the slope of the tangent line. This is where the concept of a derivative comes in. Also, the concept of a limit finally is coming to practical use. Okay, so next, let's just redraw that curve. Let's draw our parabola bigger. Okay, so here we have y equals x squared. So the way I was taught is basically, here is, let's say, this is a, and obviously this would be f of a, right? So the coordinate of this point would be a, comma, f of a. And now let's draw a second point. Let's call this a plus h. Since this is h, this x-coordinate would be a plus h. So obviously this would be, yep, that's right, f of a plus h. So the coordinate of our second point would be a plus h, comma, f of a plus h. And, okay, so now you can draw actually a secant line connecting these 2 points. So these 2 points. And how do we find the slope of this secant line? Well, you use the traditional change in y over the change in x. So here, let me just write it out so it's clear. Our first point is a, comma, f of a. Our second point is a plus h, comma, f of a plus h. So the change in y would be f of a plus h minus f of a. Change in x would be a plus h minus a, and the a cancels, so we're just left with f of a plus h minus f of a over h. So this is where the concept of the limit comes in. Here we have the slope of the secant line, but what if I wanted to find simply the instantaneous slope of this point? Well, as these 2 points get closer and closer together, which brings in the concept of a limit, they will get so close that this h would be 0, and then we should be able to find the instantaneous slope of the first point. So if we wanted to find the tangent line, which is what we are looking for, we would then ask ourselves, what would happen as h gets closer and closer to a? Sound familiar? Yes, that is a limit. So here we have finally the definition of a derivative. The limit as h approaches 0 as the distance closes of f of a plus h minus f of a over h. This, my friend, is the definition of a derivative. And your book may actually use a lot of books, such as your review book and probably your textbook, I forget, will replace h with delta x. So don't be confused, it's the same thing. And yeah, I hope that was helpful. I'm sorry if there was any confusion, but I think if you keep practicing and you see more problems asking about slope, this will make more and more sense to you. So thank you and good luck.